Continuing our discussion of game theory, we proceed. So in the examples up to this point, all the strategies were chosen with certainty. Okay, so all the players played a strategy or a move with certainty, probability 1. And these are called pure strategies. And all the equilibria encountered up to this point were pure strategy equilibria. When players are able to choose randomly from a set of actions, we have mixed strategies. So again, here is a bit of notation, and I don't want you to spend too much time understanding this. So if you should read it once and then move on. So player I has a set of M possible actions, AI. So this is his strategy set, AI1 to AI small m, all the way up to AI capital M. And a mixed strategy is a probability distribution over the M actions. So SI is sigma I1 to sigma I capital M, where sigma IM, which lies between 0 and 1, is the probability of player I playing action AIM, small m, right? And the sum of the sigmas is equal to 1, because all probabilities must sum to unity. In the Battle of the Sexes example, the two actions, A1 and A2, were ballet boxing. And a mixed strategy would be a pair of probabilities, sigma and 1 minus sigma, where sigma is the probability of choosing ballet. If we wished, we could have made sigma be the probability of choosing boxing. Either one would do, since there are only two strategies. Now, since sigma plus 1 minus sigma is equal to 1, once sigma is specified, we automatically know the probability of the other action. So in this particular context, since sigma is the probability of choosing ballet, if we know sigma, then we automatically know the probability of going to the boxing match. A mixed strategy is a general category in which a pure strategy is a special case, where sigma is equal to 0 for one of the actions. So sigma equal to 0 for one of the actions automatically means that sigma is equal to 1 for the other action. Mixed strategies in which two or more actions are played with positive probability are called strictly mixed strategies. And in the Battle of the Sexes game, the following probability distributions would represent mixed strategies. So say you had a probability distribution of 1/3 and 2/3. What does this mean? 1/3 would be the probability of going to the ballet. So automatically 2/3 would be the probability of going to the boxing match. And note that 1/3 plus 2/3 is equal to 1. So this would be a strictly mixed strategy. Also half and half. So there's a 50-50 chance of going to either the ballet or the boxing match. That too is a strictly mixed strategy. On the other hand, 1-0, that means that is a pure strategy where a player definitely goes to the ballet and does not go to the boxing match. On the other hand, 0-1 is a pure strategy where one of the players does not go to the ballet, but definitely goes to the boxing match. Now, the strictly mixed strategies and the pure strategies are all part of mixed strategies, right? The pure strategies are a special case of mixed strategies where one of the probabilities is 0, and so the other probability would be 1. Now recall the static form representation of the Battle of the Sexes game, which is reproduced here for your benefit. There are 4 possible outcomes: ballet, ballet, ballet boxing, boxing ballet, and boxing boxing. Now let us suppose the wife chooses mixed strategy 1/9, 8/9. This means she goes to the ballet 1/9% of the time and goes to the boxing match 8 by 9% of the time. And the husband chooses 4 by 5, 1 by 5, which means that the husband goes to the ballet 4 by 5% and to the boxing 1 by 5%. When we have these percentages, we can then calculate the expected payoff. We can start by calculating the expected payoff of the wife. So the expected payoff of the wife, given her probabilities and the probabilities of the husband, will be as follows. So it would be the probability of ballet multiplied by the payoff of ballet plus the probability. So when we say probability ballet, we mean the joint probability of the wife and the husband going to the ballet. When we have a joint probability of two mutually independent events, you need to multiply the probabilities together. So that's what we do. That's what we are doing here. So the probability, we have the probability of ballet times the payoff of ballet plus the joint probability of ballet boxing times the payoff of ballet boxing. So the wife is going to ballet and the husband is going to the boxing match, right? So this is how you should interpret these expressions. Plus the joint probability of boxing ballet times the payoff of boxing ballet, plus the joint probability of boxing times the payoff of boxing. And the joint probability of ballet is 1 by 9 times 4 by 5. And the payoff of ballet is, for the wife, is 2. So remember, if both the wife and the husband go to the ballet, the payoff of the wife is 2. So in that fashion, we have 1 by 9 times 1 by 5 into 0. What is 0? 0 is the payoff to the wife if she goes to the ballet, but the husband goes to the boxing match. Remember, in the battle of the sexes, the husband and wife would rather be together than be apart. If they are apart, then the payoff to either the wife or the husband is always 0. Plus 8 by 9 times 1 by 5, a joint probability of going to boxing ballet, times 0. So once again, since the wife and the husband are apart, the payoff to the wife is 0, plus the joint probability of both going to boxing, which would be 8 by 9 times 1 by 5, times the payoff to the wife of going to the boxing match when her husband is also there, and that is 1. And when we add all of these values together, notice the middle two values are going to vanish. When we add the first, so when we add the first value and the fourth value, we end up with 16 by 45. So this is the payoff, the value of the expected payoff to the wife. We can actually calculate the wife's expected payoff of playing a pure strategy of going to the ballet only. So if she goes to the ballet only, then her probability set is 1, 0. However, the husband continues with the mixed strategy of 4 by 5, 1 by 5. So when we calculate the expected payoff of the wife, given these probability values, we can proceed in the previous fashion and we will get 8 by 5. So again, this is the expected payoff of the wife of playing the pure strategy 1, 0. Now you should repeat the exercise for husband with the wife's mixed strategy unchanged, 1 by 9, 8 by 9. So the husband plays the pure strategy 1, 0, but the wife plays the mixed strategy 1 by 9, 8 by 9. So you should figure out the value for yourself. Now we can obtain a general expression for the wife's expected payoff when she plays the mixed strategy W, 1 minus W, and the husband plays H, 1 minus H. So W and H represent the probabilities of going to the ballet for the husband and wife respectively. Actually, this should be wife and husband respectively. So W is the probability of going to the ballet for the wife, and H is the probability of going to the ballet for the husband. So this should be wife and husband respectively. So please note this correction, wife and husband respectively. So as before, let us calculate the expected payoff of the wife, this time with probabilities W1 minus W and H1 minus H. So we proceed as before, joint probability of ballet times the payoff of ballet plus the joint probability of ballet boxing times the payoff ballet boxing, plus the joint probability of boxing ballet times the payoff of boxing ballet, plus the probability of boxing times the payoff, joint probability of boxing times the payoff boxing. And when we plug all the values and simplify, we get 1 minus H minus W plus 3HW. Similarly, the expected payoff of the husband when the wife plays W1 minus W and the husband plays H and 1 minus H is 2 minus 2H minus 2W plus 3HW, right? So you should be able to obtain this expression on your own. So let's focus for the moment on the wife's payoff, 1 minus H, expected payoff, 1 minus H minus W plus 3HW. Note that the wife's best response depends on H, which is the probability of the husband going to the ballet. If H is equal to 1 by 3, the value which makes W vanish. So if you plug in 1 by 3 for H, notice that 3 and 3 cancels out. So you have W, so plus W minus W is 0. So W vanishes when H is equal to 1 by 3. So you're left with 1 minus 1 by 3, which is 2/3. So when H is equal to 1 by 3, the value which makes W vanish, the expected payoff of the wife is 2 by 3. Since W is not in the picture, it means that when H is exactly equal to 1 by 3, the wife's best response is any value of W between 0 and 1. Now, W is a probability, so it cannot have a value less than 0 or greater than 1. So it could be any value in between these two numbers. Now, consider what we mean when H is less than 1/3. What does it mean? It means the probability of the husband going to the ballet is becoming quite low. H is less than 1/3. In other words, the husband is trending towards not going to the ballet. Now remember, in the battle of the sexes, the husband and wife would rather be together than be apart. So if the husband is reluctant to go to the ballet, his probability of doing so is less than 1/3. The wife should also be reluctant to go to the ballet. So if H is less than 1/3, the wife should set W equal to 0, as low as possible, in order to maximize her payoff. And by the same logic, if H is greater than 1/3, which means that the husband is trending towards actually going to the ballet, the wife should also go to the ballet, i.e. she should set W equal to 1 in order to maximize her payoff.